Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we'll be talking about logarithm today, and I'll do a quick overview about logarithm, and I'm going to explain the concept. I'm going to explain some of the rules of logarithm. All right, before I move forward, don't forget to like, share, and subscribe, and don't forget also to click the notification bell so that when I post new videos, you'll be the first person to know. All right, so let's get to it. So when we talk about logarithm basically is the opposite of a power. So basically, in other words, if we say we take a logarithm of a number, we're basically undoing an exponentiation. Is that making sense? So it's important to know that usually logarithm is the opposite of an exponent. So usually when we're trying to undo that, we do the logarithm for that. And there'll be a number of laws and rules I'm going to talk about. But for this, I'm going to talk about 16 laws, okay, of logarithm. All right. So let me let me just write down what I just said for those that are taking notes. So a logarithm. So the first thing I said was that logarithms um, is the opposite of a power. The logarithm is the opposite of a power. So basically, in other words, if we take logarithm of a number, we're basically undoing an exponentiation. Of a number, we basically undo, all right, an exponentiation. Okay, so we're basically undoing exponentiation, all right? And also we have several laws. We're going to talk about 16, but I'm going to list all the laws in this video. Then in the subsequent video, I'm going to be taking them one by one. Is that okay? But before I move on, there's something to note, okay? It's very important to take note of this, all right? The first thing is that these laws I'm going to talk about, they apply to any base, okay? They can apply to any base, but they must you must have the same base throughout the calculation. Is that okay? So they apply to any base, but you must have the same base throughout the calculation. So please, I want you to take note of this in your notebooks. So the laws apply to logarithm of any base, okay? So it applies to any base. So it could be to base 10, to base E, to base 5, it does not matter. But the same base must be used throughout. Okay? The same base must be used throughout the calculation. Okay? So for instance, if we have log base B to base A plus log C to base A, we can solve this because you can see both of them must have what? The same base. Okay? Now, the second thing I want you to keep in mind is that when you're solving logarithm, it is not possible to have negatives, all right? So negative numbers, so negative values here, logs of negative. Let me put it that way. Maybe that will make, okay? So logs or logarithm of negatives, or we have negative base. It's not possible. That's what I want you to keep in mind. So having logarithm of negatives or negative base is not possible. So what I'm trying to say, for instance, you cannot have log of minus b to base a. This is not possible. Or you cannot have log minus a, base of minus a, b. This is not possible. So for instance, you cannot say log 3 minus 5. You can't have something like this. Or you cannot have log minus 3, 5. It's not possible. So it's not possible to have negative numbers. All right. So that we've said that, and let's keep that aside now. So let us just list the rules now. Okay. I told you we have 16 laws. All right. So we have 16 laws. And I'm going to go through all of them. I'm going to just list them in this video. Then in the subsequent video, I'm going to now be explaining each and every one of them, okay? So the first one is what we call the product law, okay? So the product law is very simple. It said log a to base x plus log a to base y is equal to log a, you multiply x and y. Is that okay? So we have log a to base x and log a to base y. You multiply it, you multiply both of them here, and that'll give you log what? Axy. And before I go as well, continue, I need to also make this note as well. Moving forward, one thing you need to know is that when we say log x to base e, all right? When we say log to base e, what is equivalent is equal to ln x. So ln is the same thing as what? Log to base e. Okay? So usually I will be writing ln instead of log to base e. Okay? So log to an exponential base. So instead of me to write log to base e, I'm going to be writing ln. So for example, when we have log to base e of 10, okay? For example, it's the same thing as saying ln 10. Is that right? So all the rules apply, but the only difference is that when the base is an exponential, then it's equivalent to ln. All right? Good. So that means I'm going to talk about that as well. So I can also say ln x plus ln y is equal to ln xy. So that means I can write this, okay, as log ex, are you seeing it? Plus log ey is equal to log exy. But I'm not going to be using log e most time in this video. I'm going to be using ln. Okay? So the product law says that when you're adding two logs with the same base, you multiply them what? Together. Number two is what we call the division law. All right, the division law now is the same thing. It's log ax minus log ay. So in the first law, we're adding, but this time you subtract. And when you're subtracting, it's going to give you log a. You then divide x over y. Are you seeing it? So when you're dividing, you subtract each of them. But remember, I told you the first thing is that they must have the same what? Base. All right. So it's very important that they have the same base. So we can also apply this as well. We can say ln x minus ln y is equal to what? Ln x divided by what? Y. And that is the second law. Now we're going to go to the third law. The third law, which is called the addition law. The third law, which is the what? The addition law. So now, the law states that when we have log a, this time is x plus y. Are you seeing it? Now we are adding it together here. Now what is it going to give you? It's going to give you log ax plus log a 1 plus y divided by x. So don't worry, I'm going to have separate videos for each of these, and I'm going to explain them. But I want to just list all the laws here. Then we'll talk about that later. So the next one, when we have ln x plus y, that will give you the same thing as saying you're going to have ln x plus ln 1 plus y over x. Okay, that's the addition law. Number 4 is the what? Subtraction law. Number 4 is the subtraction law. So here we have log a, but instead of having x plus y, we're having x minus what? Y. And that will give us the same thing. It's going to give us log ax plus log a. Now, instead of having 1 plus, the difference here is going to be 1 minus y over x. And also, we have ln, same thing, x minus y is going to give us ln x plus ln 1 minus y over x. Okay? Then, number 5, the next law we'll talk about is called the exponential law. Okay, so exponential law is we have log a now is x raised to power n. So that means this power, there's a power here, all right? So you bring the power to the back. So that will give us n log a x. So that means log x to base a, all right? Now the same thing, if you have ln x raised to power n, the same thing, you bring the n to the back, and that will give you n ln what? X. Number 6. The next law is what we call the 0n law, okay? But before I go to number 6, for number 5, there are other variations of it as well, okay? So the other variations, so the first one is when you have the number here having the power. In some other cases as well, it's also possible, this is number 1, and this is number 2, all right? Now, it's also possible as well that the powers now is going to be to the base itself, okay? So there are some that have that kind of variation. So I'm going to talk about that first before I go to the 0 law, okay? So now in this case, we have what we call the exponential of base law. Okay? Now, exponential of base law. Now, in this case, we're having log. Now, instead of the x here to have the power, now is the base that has the power. Okay? So in this case, you bring the n to the front as well, but instead of having n, it's going to be 1 over what? N log a and what? X. Okay? The same thing if you have a ln, okay? So you have it as log e n x. So remember I say log e is ln, but because I want to show that the e has a power, all right? So the exponential has a power, I'm going to write it like this. It's going to be the same thing as 1 over n log e x. And we also know that log e is the same thing as what? Ln. So you can have it as 1 over n ln x. Okay, so don't worry, I will have videos for each of this. I just want to list all the laws so that maybe if you're done watching the video, you can come back to this video and just remind yourself of all the laws, and just to as a refresher before an exam or something. Number 7. The next one is what we call the 0 law. The 0 law. So what we said, log of any base but 1. Log of 1 to any base is equal to what? 0. Okay? And also ln of 1 is equal to what? 0. So log of 1 to any base is what? 0. Okay? So please don't forget that. All right, so let's go to number 8 now, okay? Number 8 is what we call the change of Bayes' law, okay? Number 8 is what we call the change of Bayes. So for instance, what we're basically saying is that if you have log b, okay, log m to base b, and I want to change this to base a, what do? It's going to give you log m to base a divided by log b to base what? A. So that's how you change it. All right. So the same thing, if we have, let's pick another one. So if you have ln m, okay. So remember that ln m is the same thing as saying log log m to base e, okay? And you want to change this to base a, is going to be equal to log m base a divided by log e base a, all right? So you have to change it this way. And that is that for that. Number 9. Okay, number 9. So the next one we're going to talk about the identity law. Okay? Identity law. Identity law is very easy. It just says that log b, when the same base are equal, so when the logarithm of a number is equal to the base, and that will give you 1. So log b to base b is equal to 1. And ln e, the ln of exponent, so the ln, remember I told you the ln is the same thing as saying log e. So the ln is log e, and the e is also here as well. It's equal to 1. So ln e is going to be equal to what? Equal to 1. Number 10 is what we call the inverse property of logarithm law. So we have the inverse property of logarithm. Okay? So inverse property of logarithm. Now, what it's saying is that if we have, it's similar to the identity law, but this time we have log b to base b, but this time the b here has a power. So it's like it's a combination of the exponential law. So remember the exponential law? I told you that you're going to bring the n down here. So the same thing, okay? You're going to bring the k down. And when you bring the k down, log b to base b, okay? You're going to have, so you have k, we now have log b to base b, and log b to base b from identity law is equal to 1. And that will give you k times 1, and that will give you what? K, all right? So when you have, when the logarithm, okay, is same thing as the base, but the logarithm value has a what? A power. The final answer is going to be to the power. So we can also say the same thing when ln of exponential raised to power k, which is the same thing as saying log e exponential k, the answer is going to give you what? K. Is that okay? Number 11. So the last one, we talked about the inverse property of logarithm. So now we're going to talk about the inverse property of exponent law. So the inverse property of exponent law. All right? So the inverse property of exponent law. So we're going to have this. So we have, if we have a to the power of what? Log ax. So the exponent, okay, the logarithm base is the same thing as the exponent. That will give you what? Equal to what? X. Okay, the same thing. When you have exponent of ln x. So remember I told you ln is the same thing as saying exponent of log to base ex. This will cancel out and that will give you what? X. So that was the reason as well. Usually, how do you cancel out ln? You take the exponent of both sides, okay? I'm going to talk about that very soon. So this is the law we apply when we're trying to cancel out ln on any side of an equation. So because we know that when you take an exponent of a ln of any number, it's equal to that number. So number 12. The next one we're going to talk about is what we call the base switch law. So the base switch law, all right? So if we have, for instance, log AB, right? Log AB, and I want to switch it. So that means I want A to come up and I want B to come down to become the base. This is the same thing as saying 1 all over log B, A to base B. Is that okay? So if you want to switch it, it's the same thing as saying 1 divided by log B, log A to base B. So similarly, if you have ln B, and you know that ln B is the same thing as saying log EB, and you want to switch it, where applicable, okay, it's very important for you to know that where applicable is going to be similar to log of exponential what? B. Then number 13. The next law is what we call the index to logarithm law. So the index to logarithm law, okay? So what we say here is that if, for instance, we know that x is equal to a raised to power y, all right? This is what we call the index. We can convert this to logarithm. It's the same thing as saying y is equal to log a log x to base a. And this is what we call the logarithm form. And also, you can also move from logarithm back to the index. So a raised to power y is equal to what? X. Is that okay? So in this case, you can go both ways. You can go from index to logarithm and logarithm back to what? Index. All right? That is that for that. So number 14. Number 14 is what we call the equivalent law. The equivalent law. So the law states that if log m to base a is equal to log n to base a. So you can see we have log on both sides and they have the same base of base a, all right? So what we are trying to say is that if you have this, these two can what? Cancel out. So therefore, m is going to be equal to what? N. Okay? It's the same thing. If you have ln of m is equal to the ln of n. Okay? I know that ln is the same thing as saying log to base e, right? What we are saying as well is that in this case, the ln here can cancel out this ln, and therefore m is going to be equal to what? N. That is law 14. Now let's go to 15. So the 15th law is what we call the derivative of logarithms. I've talked about this when I was talking in differentiation on how to differentiate, okay? But I'm gonna just state it here because it's important to just make it to complete the whole laws, all right? So if you've not looked at my video on basic differentiation and advanced differentiation, please go to the playlist and have a look at it. But I've discussed this before. So where I told you that if y is equal to log x to base b, all right? And you were told to differentiate dy over dx. Dy over dx for this is going to give you 1 all over x ln b, okay? 1 over x ln b. So I've talked about this very well. So I'll advise you go back, check the playlist and look at search for differentiation of logarithm. I've talked about this a lot, so you can have a look and we'll solve questions on this as well. All right, so let's talk about the last law, okay? The last law is what we call the integral of logarithm. The integral of logarithm law, okay? So when you're integrating log x to base b in respect to dx, what is going to give you is going to be x log x to base b minus 1 over ln b plus what? Plus c. So please, I also talked about how to differentiate as well, the basic integration. So please go back and have a look up and know how to solve these as well, okay? And these are the 16 laws we're going to talk about in this video, all right? So I'm going to start from the scratch. I'm going to start from product law, division law, and I'm going to build it up all to the integral law of what? Logarithm. And in this video series, other things I'm going to talk about later. I will talk about the laws of exponents, okay, or the exponential law, okay. And I'm going to also discuss as well the relationship between ln and exponents. We'll talk about this a little bit more, okay. Then finally, after I'm done talking about both the laws of exponent, the laws of logarithm, I'm going to solve some equations or solve some questions. I'm going to solve questions involving both logs and exponents. Okay? So I'm going to solve some questions involving both log and exponents. So it's important that you follow me in this series so you can understand that. So I'm going to use questions. I'm going to solve questions that have logs. I'm going to solve questions that have exponents. And I'm going to apply the relevant log laws to each of them and try and solve it as well. Okay? All right. So that is that for that. Okay? So I'm going to go to the next video, which will be on product law. So it's important for you to subscribe and click the notification bell. So when I upload the next video, you'll be the first person to know. All right. So see you soon.